Welcome to another episode of Code for Thought Bite-Sized. This bite-sized episode is all about Git, the version control system. And as per usual, it is the follow-up podcast for the interactive ByteSized RSE session run by Jeremy Cohen from Imperial College in London and Steve Crouch from Southampton University. Git has already been mentioned in previous sessions and episodes of this ByteSized RSE mini-series, and chances are you're using it already for your own work. Or at least some form of version control system, I hope. Git has a large number of features, and unfortunately I'm not able to cover all of them. It would take far too long, and besides, there are some excellent tutorials, introductions, courses and books available. And you will find links to some of them in the episode notes. Rather, I'm going to focus on some commands and practices I hope you will find useful. And in a few moments, I'll be talking to Raniere Silva from Gesis, which is part of the Leibniz Institute in Germany, and about how he uses Git features such as stash and cherrypick. But more about that in a moment. First, let's do a bit of background. Who created Git and when? And why is it called Git in the first place? That's the nice thing about free and open source software. You can go and find out about it easily. The Git repository from where new releases are being made available is open to all. Scrolling through the release history, you will find that the first release with version number 0.99 was made 18 years ago, that is in 2005, by none other than Linus Torvalds, who's also credited, of course, for creating the Linux operating system. As for the name, let's read in the README file what Linus has to tell us. And it is titled with Git, the stupid content tracker. I'm not making this up. Further, Linus informs us that Git means random three-letter combination that is pronounceable and not actually used by any UNIX command. The fact that it is a mispronunciation of get may or may not be relevant. Secondly, stupid, contemptible and despicable, simple, take your pick from the dictionary of slang. Third, global information tracker. You're in a good mood and it actually works for you, angels sing and a light suddenly fills the room. And finally, goddamn idiotic truckload of, a word I'm not going to use on the podcast. He finishes by saying, it doesn't do a whole lot, but what it does do is track directory contents efficiently. Well, I think there is a lot of humble pie in there, and in these 18 years of existence, Git has become one of the most popular version control systems there are. Not least probably because of its close integration with repository services such as GitHub and GitLab. And you will also find it pre-installed on most Linux and macOS machines, so you don't really have to do anything, you don't have to look for it and install it, except when it comes to Windows, for which Git installers are freely available for download. Git can be easily run from the command line, in fact it's been designed to do that, but of course there are also graphical user interfaces available, you can download them, but a discussion of those, I'm afraid, is beyond the scope of this episode. Suffice to say perhaps that GitHub has its own Git client that you can download and use for free. Before we talk about Git features specifically, it might be helpful to understand in principle how it actually works. The freely available blog on Git, the link for which can be found in the episode notes, has a great metaphor for it: snapshots. The version history is a series of snapshots. Git maintains a history of these snapshots in a repository on your computer. Services like GitLab or GitHub make these repos available as cloud-based services. But when you clone a repo from, say, GitHub, you will get it locally on your computer, which contains all the history of the Git repository until that point. Creating a new snapshot or committing changes, to use Git parlance, to your repository is facilitated by first moving them to a staging area. This is done with the command git add, followed by the name of the file or files you want to commit. And after you've moved them to the staging area, you can then do a commit using the command git commit, usually accompanied with a message, which adds the changes to the repository for the branch you're in. Each commit gets its own ID, so it can be traced later. And we come back to that when we talk about undoing changes. I'm mentioning git add and git commit because, as Raniere explains in the interview later on, they are probably the commands you will use most. Probably next to git merge, more about that later, and of course git checkout, which helps moving between existing branches of the Git repository or indeed create a new one. So let's talk about branching in a little bit more detail. If you're working in a team of developers, branching is simply a must and indispensable. But even if you're working on your own, branching can help you manage your development much easier. And why is that, you wonder? Because you can work on a branch without impacting the code that sits on the parent or any other branches. Let's say you have a version of your software that's been released, is known to work, and is used by researchers and scientists and other team members. At the same time, you want to develop new features. Or say you work in a team and your colleagues are working on a different feature than you do. In all of these circumstances, branching will help you isolate the work in progress from existing and working releases. Or, of course, other people's work. Typically, teams decide on patterns for branching. In the teams I worked with, we usually ended up with a main branch for releases, where each release was marked with a tag marking the version number for that release, a child branch called integration or sometimes development, which has been created to capture work on new versions and features that have yet not been released. And finally, feature branches, or sometimes branches for each individual developers, which are being used as further child branches to work on individual tasks. The nesting structures of these branching patterns can be very complex, but again, they can also be very simple, and it all depends really on the nature of your project and, of course, what your team decides. Raniere, for instance, will give a great example of how he uses branches when he has to take care of software releases based, for instance, on different versions of Python. Branching, of course, is all very well, but in the end you will have to bring all those changes back together again. And this is usually where things may get a little bit awry. Generally, the way to do this is to use the command git merge. This command will take the latest committed changes from a source or originating branch, say your feature branch, and merge them into the target branch by moving the changes you made since branching into the target branch. The reason this can be difficult is that sometimes you end up with conflicts or unwarranted results. And this is particularly the case if there is a large number of changes to merge back into the target branch. Therefore, the recommended way is to do the following. Avoid big merges. Merge small changes and merge them frequently. Prepare the target branch before merging, and that usually means that you have to do a commit of all the changes you've made on the target branch before the merging, because otherwise they might get lost. You can avoid committing the changes from a merge by adding the no commit option to the command. There is also a command called git stash that allows you to save any changes before the merge without committing them. And this is indeed a great feature that we will talk about with Raniere a little bit later. But let's look a little bit more detail why you want to use stash in the first place. Why do you want to save changes without committing them? Well, first, as I already mentioned, it's a way to avoid and resolve any potential merge conflicts. But secondly, it also allows you to move between different branches without the need to commit. And as your Git branching patterns may get more complex, you'll find that very useful. Going back to merge conflicts, techniques like that may help you to reduce the likelihood of merge conflicts, but unfortunately they cannot always be avoided, and you will run in a situation where you will have to resolve a merge conflict. But hopefully, if your changes are small and frequent, it will be easy to resolve them. And at least it will be easy to identify the merge conflicts, and in most cases, to be honest, it will be just a question of selecting one version over the other. And now it's time for my conversation with Raniere. Raniere and I talk about stash, how to undo things in Git, and how to avoid merge conflicts in more detail, as I've just highlighted. He's also highlighting cherrypick as a great Git command. Personally, I haven't used cherrypick that much, but I think and I hope that you will find it interesting. So here now my conversation with Raniere. Hello, Raniere. Thank you very much for joining me today. It's about Git and advanced Git features we will be talking about. Before we do that, could you quickly introduce yourself, please?
Hello, Peter. It's a pleasure to join you. Thanks for the invitation at the Collaborations Workshop. So my name is Raniere Silva. I'm a research software engineering at Gesis that provide IT infrastructure and data for social science. I'm collaborating with my Byte.org and other related projects for reproducibility of science.
I think it's part of the Leibniz Institute, is it?
Yes, you're correct. It's part of the Leibniz Institute.
And you're based in Cologne, I understand.
I'm based in Cologne.
Let's just start with what kind of Git features you use actually most. I mean, Git comes with a large number of features, but which ones are the top ones for you?
So I mostly use creating new versions, new commits. That's the primary reason to use. Moving forward, I use the diff to check what is being changed, what had been done from the previous iteration of the project. I also use the stash. I use branching both for separate features, but also for different parts of the project. And that's pretty much what I use on a more day-to-day basis.
So you mentioned a number of things that I want to talk to you about in more detail, one of which is stash. What is stash actually, and how does it help you in the development?
So the git stash command, what it does is copying all the modifications that are on your current working directory, and it put on a different location. So it basically clean up all your working directory. And all those changes, they go to a pile. That's where the name comes from, stash. For me, mostly I just put some things on stash because I need to check a different branch, get complaints that it will conflicting or it can't operate. So I stash things, then do what I was looking to do, and then I unstash. So I bring all the changes that was saved back to my working directory.
I think sort of what you're saying is that the stash is like an intermediate space. So you work on something, you make some changes to a file, you stash it, it goes into this separate space.
So you have your working directory, lots of changes. And when you do a git stash, it copy all those changes to a stash file. It gets an ID, so you can have more versions on your stash file, but it cleans up all your working directory. So the command is git stash, and you do that. And when you want to go back, there's git stash pop. So it remove the top of your pile and bring back to your working directory. If you have more things, you can keep unstashing. So git stash pop. If you want to dispose of some things, you can discard as well.
And so once it's on the stash, you can simply do a git stash pop, and then that will bring it back into your working environment. Which brings me to another question. How do you undo changes? Let's say that you stashed something, but you think, oh, well, I stashed this now, but I actually don't want to deal with it anymore. Do you simply not do a stash pop then? And how do you clear the stash without actually bringing it back, if you know what I mean?
There's an option to remove things from the stash. As I said, the pop, you get the last version on the stash and bring back to your working directory. If you want to discard that one, you can do a git stash drop. That will permanently delete all those changes. You should be careful because as far as I know, there's really no way back after you do git stash.
Okay. Yeah. So we talked about stash. When it comes to things you actually have committed, it should be relatively straightforward to actually roll back a version, shouldn't it?
Let's go back a little bit. So the stash is this kind of a commit, but doesn't get a commit ID, and it's a separate pile. And there's the stage. The stage is the intermediate step between your working directory and your commit. So you can discard things from your stage and go back before the stage. That is the git revert. There is also the option that we were saying to bring things from the git commit tree back to your working directory.
Yeah, I think we need to be, as you quite rightly say, we need to be clear about. So we talked about the stash and how you drop things from the stash or how you bring things back from the stash. We then have this intermediate stage where you can bring things back. And then, of course, you have, once it's moved from stage to an actual commit with a commit ID, then you can revert to a previous commit, right, through the use of the ID.
Yeah. So let's give a step back. So different from the stash, you have the stage. So the stage, as previously mentioned, is an intermediate step between your working directory and your commit. When you do your git add, you move some changes from your working directory to the stage. They still visible on the working directory, but Git internally save those changes on the stage. And from the stage, you go for a commit with git commit. So you have some changes on the stage. And if you want to undo those changes, you can do git reset, and that will undo the changes on some of the files that specify from the stage. So you remove that back to the last commit that you have. If you want to recover changes from a old commit that you already have an ID or a tag, you can do git revert. In the case of revert, you will be undoing one of the commits, or you can do a git checkout and you can give the commit ID and the file. So on the checkout, it copies the file as was on that commit. So it might be that it undo many changes from different commits. Where revert, you just undoing that specific commit. There is also a command called git cherrypick, and you provide also a commit. So it's not a way to kind of undo, but a way to, as the name suggests, you select things from other branches, from the top of other branches. The allegoric thing is you have your tree and there's the cherries. So those are the end of your branches. And then you can pick your cherries, pick the end of your other branch, then you can bring them to your current branch.
So in actual fact, there are quite a different routes at various different stages in the Git workflow where you can either undo things or, as you just said with cherry pick, use things from different branches. Like, for instance, your colleague is working on another branch and you quite like the changes that he or she made, and then you can bring them in through a cherry pick.
Yeah. My experience, the best advantage of the cherry pick is if you're doing a git merge, it might start to getting lots of conflicts that you need to resolve. And with cherry pick, you might avoid some of those, mostly because you getting the changes ish and bringing back. You avoid all the intermediate changes that the merge will do, or not the merge, but the rebase if you're rebasing.
Which is a nice segue into the next thing, and probably the last one. There's so much to talk about when it comes to Git, but I think one of the most common ones probably that everybody will encounter at some stage is a merge conflict. There are the easy ones that probably are easy to resolve, so you take whatever version you like best. But sometimes there are actually a little bit more complicated stuff to resolve. What is your strategy? Is there actually a single strategy at all when it comes to resolving merge conflicts?
The strategy is try to avoid to go to the conflicts. I mean, you don't do big commits, you do like small commits. That's one. The other one is to do, imagine that you're collaborating with people, so you do merges earlier on, so you avoid to have a couple of commits between when the original branch pull or merge request was created to actually when it's being merged. That's one of the best suggestions. In my experience, when I was working and sometimes I was getting lots of conflict, sometimes I would try to cherry pick my changes or rebase my changes, which helped me sometimes avoid a little bit of the merge conflict. Because one of the biggest challenges, if you have both the main branch and your feature branch has lots of commits and lots of changes, when you get the merge conflict, it's just super massive because it's the collection of changes. Rebasing my feature branch, commit by commit redoing step, which can be quite cumbersome because I have to redo the same change every time. That's why for me, cherry pick was slightly easier because I was just copying the last version of the files without having to worry too much about the diffs. As it's like my strategy, commit more often, merge more often with smaller commits and merge requests, pull requests. But if I get to the point that I have a big feature branch on a merge pull request that is creating lots of conflicts, I will try to use cherry pick from the top on a new branch.
Well, that's a very good tip. I wanted to talk about diff, but I think the branching and the branching pattern is something that is quite important because it's quite easy to branch in Git. What is your strategy of branching in development and of releasing software, using branches when it comes to software releases?
Mostly have one main branch. I create feature branches and merge them into the main branch. Most of the projects that I'm working at the moment, we have a long life cycle. Like we want our software to be operationally in the long term. Our stack, we're going to support Python 3.7, 3.8, 3.9, 3.10, 3.11. Only as an example. Every time there is a API incompatibility, you have to go and support that somehow. That's what happened for bigger projects. You can use different branches for different versions. In those scenarios, I would have like one branch for each version, and I would cherry pick things from the main branch and backport to the old versions, and then use tags for release. You could have branch for version 1.0.0, and you can have a branch for 1.0.1. But for simplicity, you might just have one branch called version 1.0.1, version 1, and then all the minor versions you can use a tag, adding the tag when you releasing the software.
Indeed. I mean, as you say, it depends really much on the kind of project that you're having. And I think it's a very good example that you have APIs where the API depends on different technology stacks, let's say on different Python versions. So at minimum, you should have something like a main branch, and then you have something like a development branch.
So you always have your feature branches where you develop new functionalities or you correct your bugs and so on. But with the continuous integration, you don't necessarily need to have a development branch. You can always merge things into the main branch and leave for all your continuous integration testing to be done on the main branch.
To protect the main branch, basically.
Yeah. If something is not working, your continuous integration pipeline will break and stop. So you don't release, you don't deploy, but everything is on the main branch. At that point, we're just going completely out of the topic. It's just like how you organize your continuous integration or your environments, and there is different ways. And yes, if you prefer to work with, you can have two different branches, like, as you say, like the main and the development. I'll say it's most like a preference.
It is, yeah. Okay, well, thank you very much for your time. It was a very interesting chat, and I think hopefully the listeners will learn a lot about how Git is deployed and the various different options you have with Git. So thank you very much for that.
Thank you.
All the best.
All the best.
Thank you for listening to this episode of Code for Thought Bite-Sized. The content and the interactive ByteSized RSE sessions are created and run by Jeremy Cohen from Imperial College London and Steve Kraut from Southampton University. The podcast episodes are produced by Peter Schmidt. Finally, we'd like to thank Universe HPC for their continuous support. And with that, goodbye.